Hi again and welcome back to our series, How to Get to Perfect Motion. In the previous videos, we showed you how to make your axes stable with feedback loop tuning and fast by finding the right acceleration limits. Today, we'll focus on jerk limits and position set point filters. With these settings, we'll make axis movements as smooth as needed to prevent vibration. Before we guide you through the tuning, let's take a closer look at why proper jerk limits and position set point filters are so important. Immediate acceleration of the axis can be heard and felt in the machine. The acceleration force causes a reaction in the mechanics. And when finishing a surface, you definitely don't want to see lines or shadows. With well-defined jerk limits, you can reduce the time for short movements. And as you know, there can be plenty of those in a part program. At the same time, you can prevent vibrations that leave marks on the workpiece. So, the goal is to smooth the motion while keeping an eye on the extra time. For this reason, STC adds additional smoothing using position set point filters. This smoothing means the actual axis position is slightly delayed, which increases the following error. In return, you get vibration damping without losing time, but at the cost of some accuracy. Please note, filter settings are defined in the tuning goal of the interpolating path axis. The recommended settings give you the best compromise between saving cutting time and achieving high contour accuracy. Also important, when tuning the jerk limits, we want to see exactly how the axis approaches the target position in a very detailed view. It's crucial to check how much overshoot the axis shows when reaching the position and whether any vibration occurs. Ideally, this information comes from the axis slide or table itself. That means from a second encoder. If you only have a motor encoder, you'll see only the major vibrations, and the amplitude will appear smaller than it actually is at the axis. So, if possible, we strongly recommend performing the tuning with a second encoder. Now let's get started with jerk tuning. In this first step, you can only confirm the step-by-step method to continue. On the next page, we'll prepare the tuning. First, check the section for open commissioning tasks. These are steps that must be completed before tuning can start. Here, everything looks good, so we can move on to initial settings. We recommend starting with a low maximum jerk value to make sure your machine isn't damaged during the measurement. If you prefer, you can switch to the current live values, the ones already used for acceleration limits tuning. In that case, you'll probably start with maximum values and then reduce them step by step. Next, STC shows the position set point filter settings required for the measurement. There's nothing you need to do here. The time constant for the filter is based on the path tuning goal in STC. You already know the section prepare machine for the measurement from feedback loop tuning and acceleration limits. You might need to set the machine to the right condition, auto mode and override at 100%. Right now, everything is fine, so we can continue with the next task. Check part program. STC has prepared a part program with several positioning steps. The axis will move to the center and then make 3 small steps to the same end position. After you've checked and transferred the part program to the machine, click the Measure and Tune button at the bottom right. As you already know from acceleration limits tuning, we'll ask you to confirm the initial values for the measurement and activate them on the machine. On the Measure and Tune page, you can see the starting values again. Click Start Measurement. STC will select the required program on the machine, which you have already tested in the previous step. Just before the program will be selected on the machine, a pop-up will appear. Click OK to continue. Then go to the machine and press Cycle Start on the machine control panel. After a few seconds, the plot will appear. It will automatically zoom to the maximum overshoot. Because of the 3 different steps, each arrival will look a bit different. In the arrival, you'll see several effects, like friction and the transition from standstill to motion, but also dynamic effects. Here, we focus on the dynamic effects related to acceleration force and how strongly it's applied. If acceleration is applied immediately, meaning with infinite jerk, the axis mechanics get a strong impulse, which usually causes a high vibration amplitude. By looking at the arrival and the vibration in the plot, you can decide whether to reduce or increase the jerk value. If the amplitude is below the overshoot tolerance and there's no visible vibration, increase the jerk. Increasing jerk means acceleration is applied more aggressively, which shortens the arrival time. If the amplitude is higher than expected or the vibration takes too long to settle, reduce the jerk. Decreasing jerk means acceleration rises more slowly, reducing vibration, but the axis will take longer to reach its final position. Here, we want to reduce the jerk value and measure again. Now we see goal achieved. Go to check results. If you want to continue with the latest jerk value, just click Finalize. On the Finalize page, STC shows all original and new values for every dynamic group. The value you determined in Measure and Tune will be applied to Dyne Norm, Dyne Pose, and Dyne Finish. Other values have been automatically increased by the software to help reduce cutting time for these processes. Please review the dynamic groups and check the resulting vibration and time behavior during cutting. You can adjust any value if needed. If everything looks good, click Confirm and activate new values to complete the jerk tuning. We'd appreciate your feedback. Your input helps us make STC even better. As always, here are a few useful tips. Jerk limits can be set individually for each axis. The NC will take these limits into account when calculating the path and generating commands for each axis. Please note, the position setpoint filter time must be the same for all path axes. It should not be tuned individually. However, you can change this setting by adjusting the tuning goal for the interpolating path axes in the section Tuning Goal. You can find the best compromise by experimenting and adjusting the path tuning goal in the desired direction. Finally, make sure the latest tuning goal is applied to all path axes by running jerk tuning with the same path tuning goal for every axis. That's it for jerk tuning. Your axis should now move smoothly without unwanted vibrations, while keeping cutting times as short as possible. In our next and final video, we'll focus on path tuning. This step will help you achieve the best possible contour accuracy and surface finish. Stay tuned.